Okay, this is the second part of the review for tomorrow. This one is buying a house in Hollywood Hills. And the house is $2,663,995. You want to buy it with 30-year mortgage, 5.25% annual interest, paying 10% as a down payment with an annual escrow payment of 1.2%. Okay. So first of all, let's figure out let's go ahead and figure out the escrow, since we're going to take that off of the top. When I say take it off the top, we're going to take it off the full amount. And that is 1.2%, so that would be the same thing as saying 0.012. And since we want to know, when I did this in class earlier, this is where I messed up. I put it towards the total cost that we want to borrow, but we don't want to do that. We want to pay for it monthly. So if we multiply by 1/12, that'll give us the monthly price. And if you do that, you get $2,664 a month. That's an escrow. That's normally a house payment, but this is the escrow for it. Okay. Now, remember, this is going to be monthly. Okay. Now let's figure out how much we're going to pay for the house. So we got 266,995. Now we're going to pay 10% down. So there's two ways to do that. We'd say times 10% and then subtract that from the original cost, or we can just say 0.9, because that's going to be how much of the house is left. Okay, so if you did this, it would equal 2397595. Okay, but if you did it the other way, like I said, you'd have to find it and then subtract it. So 2,663,995 times your down payment, you would just move the decimal place and it would be. So that's how much you would pay for the down payment. Okay, we really don't care. We know we're going to pay that much for the down payment. What we're going to care about is how much of the loan we need to get. So this is probably a better way of doing it. Let me rewrite this. Okay, because we really care about the loan and not how much we're actually paying for the down payment. Okay. Now that we have how much we're actually borrowing the loan for, that's going to be the A. This will be the AP. That's how much we're getting for the loan. But we're wanting to solve for R. So R times API over, was it 1 minus 1 plus I to the negative N? Okay. So recurring payment, we don't know, but we know that the AP is 2397595, and the interest rate is going to be 5.25. Well, not 5.25, but 0.025. I don't have the right calculator. Zero. Oh, hold on. What am I looking for? 5.25? Okay. So that's going to be 0.004375 over 1 minus 1 plus 0.004375 to the negative 360, because 12 times 30 is 360. So now let's just plug it in the calculator. Okay, there, the R will equal $13,239.61. Okay, that's a month. That's your reoccurring payment for 30 years, but you also have to add in your escrow. Okay, so what is that? 0.925. Okay, if I did all that correctly, your monthly payment's going to be $15,903 for that house. That does not sound like fun. All right. Now we're looking at the future structured saving plan. All right, so this is going to be like a problem where we want to be able to have $15 million at the end of, I'm not 15, but $1 million after the end of 15 years. Um, so it says the future value, okay, so A of F is, okay, so it's the function of the number of payments made at the point of, is an interesting function to examine. Consider a structured saving plan with a recurring payment of $450 made monthly and annual interest rate made 5.875% compounded monthly. State the formula for the future value of the structured plan as a function of the number of payments made. F of a number, or an F of the formula. Okay. So first thing we're going to do, I would say the first thing I would do is I would go ahead and change this to a decimal. It's made monthly. Um, so what are we wanting here? We're just setting up using the F as the function. Um, seems like I'm missing something for this problem. Okay, maybe not. We're just going to set it up then. F of X, where X is going to be your, well, let's not call it X, let's call it N, F of N. We're used to it being N, F of N. All right, we're used to it being alphabets, but in our formula, it's F of N. So N is going to equal our reoccurring payment, 450. Okay, 1 plus, let's see here, what is, yeah, we can go ahead and do that. 0.5875 divided by 2. Now let's just leave it. It looks better like this because it's a really long decimal. Plus 0.0875, sorry, 5875 over 12. And then that's going to be to the n minus 1 over 0.05875 over 12. So now, what's happening here is you can plug in for however many years you want. You would have your you would have how much money you would have in the savings account. Okay. So, for example, if we ended up saying, um, let's say 6 years. Well, 6 times 12 is 72. So you would plug in 0.05875 over 12 to the 72nd minus 1 over 0.05875 over. Okay, if you did that, you would end up having, after 6 years or 72 payments, you would have f of 72 is equal to $38,732.62. So as you can see, if you can just save $450 a month for just 6 years, okay, I know it sounds like a long time, but at that type of interest rate, compounded monthly, it ends up being almost $40,000 just in 6 years. Okay, I think that's it.